For decades, the automotive industry absorbed new technology in highly predictable cycles. In the 1990s, dealerships transitioned away from physical records and paper ledger systems, migrating their operations onto digital dealer management systems. When customer relationship management software arrived in the 2000s, it required a significant operational adjustment. But organizations enjoyed a standard 12 to 24 months to evaluate vendors, pilot the software on a few isolated desktop computers, and train their staff. The technology waited for the business to catch up. This chart illustrates why that historical cadence is now obsolete. The flat, linear line represents the predictable improvement of traditional automotive software. The sharp upward line is the trajectory of modern artificial intelligence. AI operates on an exponential compounding curve. The improvement from one generation of models to the next multiplies rather than adds to previous capabilities. We are watching a capability stacking effect in real time. Modern systems do not wait years to introduce single features. Within months, models that could only generate text learn to analyze video, coordinate parallel workflows, and make autonomous decisions. All of these capabilities arrive and stack simultaneously. Dealership groups structuring their technology decisions around an 18-month traditional software evaluation cycle are applying linear timing to an exponential reality. A year spent waiting to make a decision results in falling multiple generations behind the current state of the technology. To see how this misalignment plays out operationally, we can look at a composite case study. Cascade Automotive Group is a highly successful fictional organization operating 22 dealerships across 14 different brands. They generate roughly $3 billion in annual revenue. Over the last 3 years, Cascade's leadership aggressively pursued artificial intelligence. They spent $4.2 million licensing, implementing, and training staff on 5 specific AI tools, including service scheduling bots, digital retailing add-ons, and dynamic inventory pricing algorithms. By every traditional metric, the initiative succeeded. The service AI optimized bay utilization. The BDC tool improved customer response times at the stores where it was deployed. Each department measured a positive return on investment. But inside the dealership, the operational reality looks completely different. Store-level managers are spending hours each day manually reformatting data from one system to paste it into another. Frontline employees are complaining of extreme tool fatigue, and Cascade's executive team wastes a third of every leadership meeting trying to reconcile conflicting reports from incompatible platforms. Cascade bought highly effective AI tools for individual departments, but those individual purchases failed to create an intelligent organization. Here is exactly how that failure happens on the floor. A customer submits an online inquiry, and the AI tool in the BDC instantly optimizes a customized email response to schedule a test drive. But that BDC tool is completely blind to the service department software, which has flagged the customer's current trade-in vehicle for a critical safety recall. Meanwhile, another customer spends 40 minutes meticulously configuring a vehicle on the dealership's digital retailing platform. That rich behavioral data gets trapped inside the website's software silo. When the customer walks into the physical showroom 20 minutes later, the sales team treats them as a totally cold prospect. This phenomenon is called coordination debt. It is the hidden organizational penalty a company pays when it introduces intelligence through disconnected tools instead of a shared architectural foundation. Every new software purchase creates an isolated pocket of data that refuses to share its context with the rest of the building. Because the machines cannot communicate with one another, the burden falls entirely on the staff. Human employees become the manual connective tissue required to bridge the physical gaps between highly advanced software systems. The ultimate irony of departmental AI is that it actually increases operational drag. It successfully optimizes individual silos, fragments the overall business logic, and leaves the human workforce working harder to coordinate the mess. This diagram illustrates the Automotive Intelligence Pyramid. Most of the industry sits at stage 3, functional intelligence, where isolated departmental AI produces accurate insights. But directly above is the coordination ceiling. You cannot scale these isolated tools because they cannot share context. When executives feel the friction caused by this ceiling, too many dashboards, overlapping software, data silos, their instinct is to buy yet another integration tool to fix the problem. They add another fragmented node to an already broken network. Breaking through that ceiling into stage 4 requires a complete shift in procurement strategy. You cannot buy your way past the barrier with individual tools. You have to design an intentional structural foundation. The cure for coordination debt is intelligence architecture. It requires abandoning fragmented software decisions and building a 3-layered foundation that allows the entire enterprise to share a single reality. This diagram models the first requirement, a unified data lake. Right now, a dealership's customer and inventory records are split across CRMs, management systems, and OEM portals. The data lake physically extracts that information from the isolated silos and pulls it into a single continuous repository. The second layer is the knowledge hub. This system ingests dense, unstructured information, like OEM warranty manuals, HR policies, and training playbooks, and vectorizes it. Vectorization converts raw text into numerical coordinates, allowing machines to understand the conceptual meaning of dealership operations rather than just scanning for keywords. Once the data and knowledge layers are in place, you deploy agentic AI. These are active, specialized agents that operate on top of the shared foundation. Instead of waiting for a human prompt, a service agent can autonomously detect a pattern of brake repairs, instantly coordinate with a sales agent to review inventory, and prompt the BDC agent to prepare a specific customer outreach strategy. With these 3 layers built, human employees no longer act as manual data translators. They shift to reviewing and approving workflows orchestrated by the machines, allowing the dealership to behave as one highly coordinated organism. This structural design is available today, and the timing of its adoption is directly tied to the exponential math we examined earlier. When an organization implements true intelligence architecture, they achieve competitive asymmetry. Their agents immediately begin learning operational patterns across every location. And because of the compounding curve, that institutional knowledge multiplies itself month over month. This graph models what happens to late adopters. These are 2 identical compounding curves, but because the technology scales exponentially, a dealership that waits to build their architecture cannot simply buy the accumulated learnings of their competitor a year later. They have to start their compounding from 0, staring up at a mathematical gap they can never close. Traditional 18-month software procurement cycles are a luxury the industry no longer has. The window for making deliberate architectural decisions is actively narrowing as the technology accelerates. The conversation in the boardroom is no longer about whether to adopt artificial intelligence. It is a stark choice between continuing to accumulate fragmented tools or building the underlying architecture required to survive the intelligence age.